Today we're going to begin Chapter 1, Exploring Data. So once you have done an experiment or an observational study and you have all of this data to look at for your subjects, what do you do with it? So that's what we're going to talk about today. Okay, so let's just get into some basic vocab. Some of this you have to write down on your notes and some of this you don't. So statistics is the science of data. And data analysis is the process of organizing, displaying, and summarizing that data and asking questions about it. Two words that we've kind of already talked about from Chapter 4, individuals. Those would be like your experimental units, your subjects. So in our question of K-Park students' heights that we talked about in Chapter 4, K-Park students would be the individuals, and a variable would be a characteristic of that individual. So their heights would be the variable. Let's talk about the types of variables. There's two different types. One of them is categorical. This places the individual into one of several categories. So a category is going to be something like type of car you drive, favorite color, favorite pizza topping, are they married, single, or divorced? It's anything that is not a number. Okay, so usually it's a yes or no question, or it's an option so that they can choose from, but they are not numerical values. Then there's quantitative variables. Quantitative variables take on a numerical value. So height, weight, age, income, their amount of student loans that they owe, GPA, class rank. Those are all quantitative variables. Okay. Now, really quick, let me just clarify that a range of values can be put into categorical. So for example, if I was going to separate people into age groups, so I was going to say someone from the age of 13 through 19, 20 through 30, 31 through 40, and so on, those groups of age groups are now considered categorical. Okay, because it's a category. We put that person into an age group, into a category of an age group. A quantitative variable is something that it makes sense to take an average of. If I had age groups and I didn't know how old the person was specifically, I just knew that they were in an age group, it doesn't really make sense to take an average of that value. So be really careful with that kind of stuff. But categorical is something usually that is not numerical. It's a category. It's something about them, their hair color, their eye color, okay? The types of shoes they like to wear, those kind of things. Quantitative are variables that have numerical values, something that you could take the average of. I could take the average height, the average weight, the average age, the average GPA. I can do that in those kind of variables. Okay, so a variable can take on many different values. In statistics, we're interested in how often a variable takes each of those values. So we're going to look at a table here. So first, you need to write this down. Distribution tells us what values a variable takes and how often it takes those values. So we have a table here. In this table, it gives us the model of the car that certain people drive and the miles per gallon that the car gets. Okay, in a table, it's not really easy to compare them because the numbers are not in any specific order. It's hard to see when you're dealing with a table. So what we like to do is figure out what our variable of interest is, what we care about, and turn it into some sort of graphical display. So in this case, my variable of interest is the miles per gallon. I care how many miles per gallon each of those cars gets. So in this case, we're going to turn it into a dot plot, which we'll talk about how to create dot plots a little bit later when we get to our other types of distributions and we start looking at how to actually make distributions. But this is just an example. We've taken this data, turned it into a graph, and now it's much easier to see kind of the shape of that graph, where a majority of the miles per gallon fall. It was a lot harder to see that in the table. So distribution helps us look at it and see where would the majority of them fall, where would the center be, that kind of stuff. So today, we're only going to get into categorical data. So we're only going to really focus today on categories. We're not going to make any distributions today that deal with quantitative variables. Remember, quantitative are numerical values that can be averaged. We're going to focus on categorical today. Okay, so just a reminder, categorical variables place individuals into one of several groups or categories. So in this table, we've got different radio stations and the different types of music that they play. Our variable is the format of the music, so the type of the music. Okay, it's just the category. The category is format. Then we have the values of that variable. So our values are the actual types: adult contemporary, adult standards, contemporary hit, and so on. So those are the values. So our variable is format. The values of the variable are the types in that format, the options. Then we have counts and percents. The counts are literally a count. If I were to go through every single station at this town and count how many had adult contemporary, how many had adult standard, and so on, that's how many stations actually have that type of music. It's the count of them. I can physically count them. The percent is a percentage of the total. So I take the total amount of radio stations, which is down here at the bottom, and I take each category and divide it by that total. That's where they got these percents here. Okay, so sometimes the table is shown in counts and sometimes it's shown in percents. So tables or frequency tables can be difficult to read. We talked about that a little bit a couple of slides ago where we looked at the dot plot of the miles per gallon for the cars. It's kind of hard to compare the miles per gallon when they're just in a table like that. So sometimes it's easier to analyze the distribution by putting it in a bar graph or a pie chart. So we did a dot plot for the previous data because it was quantitative. Miles per gallon is a quantitative amount. I can average those numbers. In this situation, the stations, radio stations, is not quantitative, it's categorical. So the only options I have for categorical data is a bar graph and a pie chart. So you might want to write that down on your notes. We only use bar graphs and pie charts for categorical data. So we've shown here when we did the bar graph, which is the one on the left-hand side, we use the counts. So we have all of the different types of radio stations at the bottom. Okay, we have a scale going up the side of how many we could have in each group, in each category. And then our bars go up to the amount that's in each category. Okay, it's much easier to look at this and see how many stations were in each group and kind of look at like where's the majority of them, which group has the most, which group has the least. It's much easier to see it on the bar graph than it is on the table. Now, on the right-hand side, we have percent of stations. So here they took the percentages that we had in that right-hand table and they made a pie chart out of it. So hopefully most of you are pretty familiar with pie charts. You've seen them before in the past. They're pretty standard charts to be used on commercials and things like that. So they gave us a key on the side here that tells us what color represents which type of music, and then our chart matches that with whatever proportion of the chart needs to be colored. Now this you need to write down. So bar graphs compare several quantities by comparing the heights of bars that represent those quantities. In this class, we will focus mostly on bar graphs. There will be a few pie charts that you need to be able to read, but it's pretty basic just reading pie charts like normal, like you've done in previous math classes. The bar graphs are the ones we're really going to focus on. So our eyes don't just react to the height of bars. They also react to the area of the bars. Okay, so when we draw a bar graph, we want to make the bars the same width. We don't want to have some that are really skinny and some that are really fat, because it tricks our eyes and our brain into thinking that the ones that are fatter have more significance than the ones that are skinnier. So here's just kind of an example. In this case, they used pictures. So you also don't want to use pictures. So it says it's tempting to replace the bars with pictures for greater eye appeal to make the graph look better, but it actually messes up your data. Because if you look at this here, these are number of buyers of computers and then what their previous computer was. So they either had no computer, they had a Windows computer, or they had a Mac computer. So if you look, the people who had no computers, they're about right here at the 100 line. Okay, so people who had no computers in this set bought 100 computers around. The people who had Macs bought about 350 computers. But if you just looked at the pictures, the Mac people look so much bigger than the people who had no computers because of the picture. So in the picture, it seems that it's not just a 3.5 times as many people. It looks like it could be 10 times as many people, because not only is the picture of the computer taller, but it's also wider. So it's the same kind of concept as with the bars. It makes it look like it has more area, more mass, so it makes our brain think that it's a bigger difference. Advertisers will use this sometimes to make their product look better than it actually is, so be really careful with that. In this class, you will never, ever, ever use pictures or uneven bar widths to make charts. Okay, so just keep that in mind. So it is tempting to replace the bars with pictures for greater eye appeal. Do not do it. Okay, so now we're going to get into two-way tables and marginal distributions. So when a data set involves two categorical variables, all the data sets we've looked at before have always involved just one. When it involves two, we need to begin examining the counts or percents for various categories. Okay, so we're going to look at one of those. So a two-way table, you need to write this on your notes, describes two categorical variables, organizing counts according to a row variable and a column variable. We're going to look at an example. So here we have young adults by gender and chance of getting rich. So those are our two variables. We have their gender, male and female. That's the first variable. And then we have their chance of getting rich. Okay, so what they did was they took a group of young adults and they asked them, what do you think your chances are of getting rich? And then they separated them based on male and female. So almost no chance, some chance, but probably not, 50-50, a good chance, or almost certain. Okay, then they took whatever they got for their values and they put it into their table here. Okay, so the two variables described by this two-way table, this question here, your answer is chances of getting rich and gender. So make sure you write those down as the answers. How many young adults were surveyed? So how many people were surveyed total is what they're asking here. When you have a table that gives you the totals in the margins, so here we have the totals for the question of chances of getting rich, and then down here at the bottom we have the totals of the question of whether they're male or female. How many people in the entire sample is going to be the total down here in the very, very bottom. Do that in different colors. So right here. That is your total for how many were surveyed. So 4826. This is just kind of going over how to read a two-way table. The marginal distribution of a categorical variable in a two-way table is the distribution of values of the variable among all individuals described by the table. So it says, note, percents are often more informative than counts when comparing groups of different sizes. So if I took two groups of people, one had 100 in it and one had 50 in it, and 20 of the 100 answered yes to a question, and 20 of the 50 answered yes to a question. If we just look at the count, 20 and 20, they look the same, but they're different sizes. So 20 out of 100 is much different than 20 out of 50. So it's better to compare the percentages rather than the counts. That's what they're talking about here in this note. So marginal distribution, just to kind of, it goes along with the word margin. So marginal means you're looking at the margins of the graph, where the totals are at. So how do we examine a marginal distribution? Number one, we're going to use the data in the table to calculate the marginal distribution in percents of the row or column totals. So we want the actual percentages of the row and column totals. We're going to look at an example on how to do that in just a little bit. And then we want to make a graph to display the marginal distribution. So like I said, we're going to do an example in just a minute. Right now, we're just going over the basics. So in our previous problem, if I asked you to examine the marginal distribution of chance of getting rich, that means I only care about the totals that go with chance of getting rich. I don't care about these totals down here at the bottom. I only care right here about these. I care about the totals that go with the options of whether or not they think they're going to be rich. Okay. So what I'm going to do is I'm going to take each one of these and divide it by the table total. So 194 divided by 4826. You're going to have to excuse my handwriting on this. It's not the best. So 194 divided by 4826, which we have right down here. So we take each one. So we have 194 divided by our total, 712 divided by our total, 7416 divided by our total, and so on. Okay, and we get the percentages. So that gives us the percent. By the way, this should always add up to 100. So if you're doing marginal percents and it's not adding up to 100, you've done something wrong in your calculations. So make sure that you're checking on that. Now you could be a little bit off, 99.9, 100.1, because of just rounding errors. That's okay. You just need to be as close to 100 as you can be. So what we do then is we take our percentages and we turn that into a graph. Because in this table, I have a different number of males and females. So when I'm trying to compare, I need to compare them based on percentages. There's a different total in each group, so it has to be based on percentage. So here we took our 4%, is right there represented, and so on. So it's much easier to kind of see where people think. This is almost none. This is almost certain. So as we go up in the scale of their chances being good or not, people tend to think they're going to be rich more. So we can see on this graph that people who think that they don't have any chance hardly are a lot smaller than the people who think that they have a 50-50 good chance or almost certain. So we can compare the data a little bit easier. Okay, so marginal distributions, one more time, are along the margins. You're always going to use the totals along either the right-hand margin or the totals along the bottom margin. Okay, conditional distributions deal with specific values in the table, so cells. One number in the table, not the margins, not the outside part, not the totals. So really quick to just kind of go through how we would do that. Okay, make sure you write down the definition for conditional distribution as well. How to compare conditional distributions. Number one, we're going to select the row or the column of interest. We're going to use the data in the table to calculate the conditional distribution in percents of the row or column. We're going to make a graph to display the conditional distribution. And we can use a side-by-side bar graph or a segmented bar graph, and we're going to look at that in a second. so let's look at our distribution that we had of male and female versus what they think their chances are of getting rich. So it says calculate the conditional distribution of opinion among males. Examine the relationship between gender and opinion. So because it says among males only, for now, we are not going to pay attention to these numbers here. We don't care about the females. We only care about the males. Okay? So we're going to do exactly like we did for the marginal distribution, but instead of taking the marginal total divided by the table total, we're now going to take the total in each cell here of males and divide it by the total number of males, because that's all we care about. We don't care about the females, and our totals on the edges include the females. So as you can see in this table down here where the arrow went, 98 divided by our total, 286 divided by our total, and so on. That's going to give us the percentages of males who think they have each of those responses. They went ahead and did the same for females. So they did 96 divided by the total of females, 426 divided by the total of females, and so on, and that's where they got these numbers here. And they chose to make a segmented bar graph. So a segmented bar graph starts off with, it doesn't really matter the order that you put these in. They started off with almost no chance down here at the bottom in the light blue. So you can see in the key right here, almost no chance is light blue. So that one only went up to 4%. And then they add the percentages on each time until they reach 100%. So this kind of shows where they're at size-wise on each type. Okay, so this table makes it easier to compare. The question says, can we say that there is an association between gender and opinion in the population, that's a really important word there, of young adults? So they're not asking us in these samples, is there a relationship? Because looking at the samples, it looks pretty similar. It looks like all of our segments are different colors for the males, closely matches the females. We can kind of see that some chance is a little bit bigger in the females and almost certain is a little bit smaller in the females. But we can make determinations of the two groups in our sample from this chart. However, right here, making any statement or determination about the population of all men and women, young men and women, would require formal inference, which we won't get into until the very last chapters of the book, which is next semester. Okay, so just keep that in mind. If questions are asking you about, does a sample give us any representation of a population at this point, the answer is we can't really make that determination. Even a strong association between two categorical variables can be influenced by other variables lurking in the background. Confounding variables. So there could be, we talked about that in chapter 4, there could be something else that's making it look like they're the same. So just keep that in mind. Okay, so now we're going to get into an example where we actually are going to do some marginal and conditional distributions here. So remember, marginal is along the margin. So it's the totals or percentages along the margin. Conditional is a cell. So like each individual cell of each category. Okay, so the first question on your example says, question number 1, well, first of all, we're dealing with Bush and Kerry voters from the Bush and Kerry election years back. They basically looked at a sample of people. They asked them who they voted for, and then they asked them what their highest level of education was. So no high school graduation, some college, college grad or post grad. Okay, so here's the data right there. So for example, the 268 is 268 people voted for Bush who had no high school. Okay, so the first question says find the marginal values and place them in the chart. Values is a really important word there. Values is counts. So what are the actual numbers that belong in the totals? And when I made your table for you on there, I went ahead and left you some spaces. Sometimes they won't leave you spaces in there for you to write your stuff. I did. That's what these are here. These are spaces for you to write your marginal totals. Sometimes they won't do that for you on the AP exam. Sometimes they won't have that. If they don't, you just make another column and another row and do them on there. Okay, so all you're going to do, so if we want the total for no high school, we're going to add 268 plus 273, and we get 541. Okay, and then we continue down the line. 1563 plus 1412, 2975. We're going to keep going until we have all of our right-hand margin filled in except for the table total. We're going to wait on the table total. Okay, so the next set, 2360, 2011, add those together, 4371. And college grad, when we add those, 3481, and post grad, 2164. Okay, I'm kind of going quick through this because I'm hoping you don't have issues with adding. You're just adding straight across. Okay. Now we're going to add up all of the Bush voters and get our total down at the bottom. So 268 plus 1563, 2360, 1847, 962. You add all of those up and we should get a total of 7,000. And we do exactly the same for all of the carry voters, and we should get a total of 6532. Now, for your table total, you can either add up all of these, or you can add up all of these. It doesn't matter. Now, obviously, the bottom two are going to be the fastest ones to add up. But here's the thing. To double check your numbers, I always add up both the column and the row. So both the right-hand margin and the bottom margin, because if you've added your numbers correctly, they should both come up to the same answer. So that's a way to kind of check and make sure that your table is set up correctly. So when we add all of those up, the easiest being the 7,000 and the 6532, we get 13,532. So they asked 13,532 people total. 7,000 of them were Bush voters, 6,532 were carry voters, and then 541 had no high school, 2,975 were high school graduates, and so on. Okay, so that's how we read this table. So go ahead and make sure you have that filled into your table on your notes. Now we're going to move to question 2. Okay, so question 2 says find the marginal distribution of education in terms of percents. So they're asking you for the marginal, which means the margin, distribution of education. So we're going to look at the totals for the education counts, not the carry and Bush voters. So we're going to be looking at the right-hand margin. That's your totals for education. And we want it in percentages, which means we have to take each of the totals and divide it by the table total. Okay, so I'm going to go ahead and put that down there for you guys. So we have no high school graduate, some college grad, and post grad. I'm making a new table for this. I suggest that you do that as well. And then I took each one. So on no high school, we had 541. We divide that by our table total of 13,532. And then we do the same for all of the other totals. Okay, I'm going to give you a few seconds to get at least a couple of those done. Do them in the calculator. Make sure that you're actually getting the values that I'm about to show you. Because just watching me do it on the notes here on the video is not going to help you when you're actually doing it on the AP exam or my test. So make sure that you're typing it in. I know it seems simple, but you don't want to mess up on a test because of a simple calculator problem. So make sure you're typing it in. Okay, after you've typed them in, you should get these values. So make sure that you double check. So we have 4% out of our total people that we surveyed had no high school, 22% high school grads, 32.3 some college, 25.7 college grads, and 16 were post-grad. Again, if I add all those numbers up, I equal 100 or a number extremely close to 100. Remember, we talked about sometimes rounding errors can give you problems. This one does actually equal up to 100, so we should be good. So those are our marginal, or is our marginal distribution of education in terms of percent. We looked along the margin, used the totals, found the percentages for only education. We don't care if they voted for Bush or Kerry at this point. And now we're going to move to question 3. So question 3 says, find the conditional distribution of education among, should say both Bush and Kerry voters. Okay, so basically what we're trying to find here is we want conditional, which means we're going to be looking at individual cells underneath Bush and Kerry voters. So we still want it of education, but we want it among the Bush and Kerry voters, we want a percentage. So we're going to take the first number under Bush, so no high school, so the people in Bush who had no high school, we take that out of the total number of Bush voters. So our first one's going to be 268 divided by our total Bush voters of 7,000. So this time we're only looking at Bush, comparing how many in each category for Bush voters only. So 268 Bush voters had no high school out of 7,000 Bush voters. So we don't care at all about Kerry right now. Okay, so we do each one, 268, 1563, 2360, and so on. Divide all of those by 7,000 because that's what we care about. And we get these percentages, 3.8, 22.3, and so on. Then we're going to do exactly the same thing for the Kerry voters. So this time, though, we're taking it out of a total of 6,532 because that's how many voters there were that voted for Kerry. And now we look at each individual cell under Kerry and divide it by that total. And I went ahead and gave you the percentages there. Okay, so these are conditional percentages. It's a conditional distribution of education among both of the voters.